Okay, so you've probably heard this story by now, right? AI data centers are sucking up so much power, they're literally running out. But what if I told you the problem isn't what we think it is? It's not about a shortage of electricity. Nope, the real villain is this hidden piece of hardware that's bringing the entire system to a grinding halt. I mean, the headlines are just everywhere, aren't they? AI is thirsty. It's absolutely feasting on our power grids. And we're talking about a huge amount of power. Think about it. The computational muscle needed to train these massive language models means some of these new data centers are using up to 10 times more electricity than a normal one. That's creating a strain like we've never seen before. But, and here's the big twist, it's not actually a generation problem. Seriously. Even if we could snap our fingers and build 100 new nuclear power plants tomorrow, it wouldn't solve the core issue. You see, generating more power, that's only half the battle. The real challenge is getting all that juice where it actually needs to go. So if it's not the power plants, then what in the world is it? Well, let's talk about the real power villain here. We're looking at a super unglamorous, totally overlooked piece of hardware that, believe it or not, decides if these multi-billion-dollar data centers can even plug into the grid in the first place. So let's meet our villain, the transformer. And no, not the Optimus Prime kind from the movies, unfortunately. We're talking about these huge, heavy-duty machines that manage the flow of electricity. And right now, I'm not exaggerating, these things are the single biggest bottleneck holding back the entire AI revolution. Okay, to really get what's happening here, let's use a metaphor. Picture this, a brand new, high-performance Ferrari stuck on a totally broken road. So, in our little story, AI's incredible processing power, that's the Ferrari. It's sleek, it's powerful, and it's capable of mind-blowing speeds. All that potential just sitting there, ready to be unleashed. But the power grid, the cables, the substations, and especially those transformers we just talked about, that's the road system. And it's not a super highway. It's more like an old, crumbling network of back roads with potholes and broken pavement. It just wasn't built to handle this kind of traffic. And here's the bottom line, right? A fast car on a broken road goes absolutely nowhere. It doesn't matter how powerful your Ferrari is if the road is completely washed out. Without the right transformers to fix this road, all of AI's incredible power is just stranded. So you might be asking, what exactly makes these transformers the all-powerful gatekeepers of the grid? Well, it all comes down to a really simple two-step process. Okay, step one. At the power source, a transformer cranks the voltage way up. This lets electricity travel super efficiently over hundreds of miles. Think of it like the electrical highway. Then, step two, when that power gets to its destination, another transformer has to step the voltage way down to a safe, usable level for something like a data center. And you absolutely cannot skip that second step. I mean, the stakes could not be higher. If you don't have that specific step-down transformer, that raw, high-voltage electricity would just blast in and completely fry the data center's super-sensitive equipment. We're talking a multi-million-dollar light show and then poof, darkness. All right, so a hardware shortage is bad enough, right? But that's only one layer of the problem. It's actually being made 1,000,000 times worse by a crazy market issue, something called the phantom demand horde. Yeah, it's clogging up the whole system. So check this out. Getting grid access for a massive AI data center isn't like plugging in a toaster. It's not plug and play at all. There is a brutal, super long queue. So what are the big companies doing? They're rushing to reserve power for data centers that don't even exist yet. And they're booking way more capacity than they'll ever need just to hold a spot in line. The crazy part is, the grid can't tell the difference between a real project and a speculative one, so it just treats all these requests as real, and that creates this massive, totally artificial traffic jam. So, how long is that traffic jam? Get ready for this? When you pile all that phantom demand on top of an already real shortage, the wait time for just one of these big, specialized step-down transformers can be up to 4 years. 4 years. And basic economics, right? When demand is through the roof and supply is in the basement, what happens? Prices explode. Since just 2020, the cost of these transformers has shot up by 70%. 70! That means only the biggest of the big tech players can even afford to get in line, which is totally boxing out any smaller competitors. Oh, but wait, it gets worse. The actual raw materials you need to build these things, we're talking copper and this really special kind of electrical steel, their prices have also doubled. Finding this stuff is becoming like finding legendary loot in a video game. It's just incredibly rare and unbelievably expensive. So the obvious question here, the one you're probably thinking, is why don't we just build more? Right? With demand this insane, why isn't every factory on the planet just churning out Transformers 24/7? Well, the answer goes way back, and it's got deep historical and economic roots. Let's do a quick history lesson. Back in the 1970s, the American transformer industry was absolutely booming. But then the 80s hit, and a lot of that manufacturing got shipped overseas. Fast forward to today, and the US relies on foreign countries, mostly Mexico and China, for about 80% of its supply. There's just not enough capacity at home to ramp things up quickly. But even if we could just flip a switch and build new factories, there's this huge economic fear holding companies back. It's called the bullwhip effect. Basically, companies are terrified of a classic boom and bust cycle. They just saw this happen with semiconductors, remember? They invested billions to meet all that pandemic demand, and then the demand just collapsed, leaving them with a massive oversupply. Nobody wants to make that same billion-dollar mistake again. And that brings us right back to our metaphor. We can keep building faster and faster Ferraris by generating more and more power. But what's the point? It's completely pointless if the road system, our grid and its transformers, is fundamentally broken. And that raises a massive question that, for now, the industry seems happy to just ignore. What happens when we completely run out of road? And that's our breakdown for today. Look, if you want to stay ahead of the curve and really understand the hidden forces shaping our digital future, do us a favor and hit that like button, and be sure to subscribe for more tech explainers just like this one.